Good day, students, and welcome to another chemistry class. Today we'll be considering the topic chemical combination or chemical bonding. And I've put the introduction here on the board. The atoms of the noble gases, like example of the noble gases, helium, neon, argon. If you write the atomic configuration, you will see that they have a complete outer shell. Like helium that has only 2 electrons and has only 1 shell. So that first shell can take a maximum of 2 electrons. That means they have a complete outer shell. Neon has 10 electrons and the atomic configuration will have 2, 8. That means the outer shell has complete electrons. That's 8. And then argon with 18 will have 2, 8, 8. That one too also have a complete outer shell, and therefore they are stable and chemically unreactive because their atomos shells are completely filled with electrons. But atoms of other elements are unstable because their atomos shells are not completely filled up. Therefore, their atoms acquire stable gas structures by forming chemical bonds between one another. This is the reason for chemical combination. So we are saying because the other elements have incomplete outer shell, all of them want to become like one of the noble gases with a complete outer shell, okay, filled up with electrons. So that is the reason for which atoms go into chemical combination, either by gaining electrons or by losing electrons or by sharing electrons so that they can have a complete outer shell. So now, what is chemical combination or chemical bonding? Chemical bonding is the coming together of atoms of the same or different elements in order to form stable molecules or compounds. Okay? And you remember that we have something that we call the octet rule. Octet means 8. So octet rule is talking about having 8 electrons in the outer shell. And what is the octet rule saying? The octet rule states that an atom continues to lose, gain, or share electrons in order to have 8 electrons in the outermost shell. That is what the octet rule is saying. So this is the basis for which we'll be talking about chemical combination because of all these issues we have raised. Now let's go to the types of chemical combination. There are 4 basic types of chemical combination and they are listed here. The first one is electrovalent, which we also call ionic bonding. Then we have covalent bonding, and then we have coordinate covalent, which we also call the dative bonding. Then the 4th one is metallic bonding. These are the 4 types of chemical combination. Now we are going to pick them one by one and then discuss them and see how to go about them. Okay, let's now take a look at electrovalent or ionic bonding. In electrovalent or ionic bonding, there is complete transfer of the valence electrons of a metal atom to the valence shell of a non-metal atom, so that each atom acquires a stable noble gas electron configuration. Okay? I'm sure we remember what valence electrons means. We say valence shell is the last shell of an atom, and then the electrons in that last shell are what we call the valence electrons. So in electrovalent or ionic bonding, it usually involves a metal and a non-metal. Electrovalent or ionic bonding is between a metal and a non-metal. The metal usually loses its valence electrons, and then the non-metal accepts electron to complete its valence shell. So that's what happens in electrovalent bonding. Let's take an example. The formation of sodium chloride, which is between sodium and chlorine. This is the electronic configuration of sodium. Sodium has atomic number of 11. And if you write the electronic configuration, you will see that it has 1 electron in its outer shell, which is its valence shell. Or if you write it this way, 2N1. You see the outer shell has 1 electron. Then for chlorine, this is the electronic configuration of chlorine, okay? And you will see that the valence shell is shell number 3, and all these ones are in shell number 3, okay? And the number of electrons here are 2 plus 5, which is 7. Now, you can see that for sodium to have a complete outer shell, is either it loses this one electron goes off, and then you are left with 2, 8, a complete shell, or it has to look for 7 additional electrons so it can have 8 here. But which one is easier? It's easier for sodium to lose this one electron and have an inner 2, 8 configuration than to look for 7 electrons. It's more difficult. So for sodium, it obtains the octet configuration by losing the outer electron, the valence electron, okay? And then it will be left with 2, 8. But for chlorine, that has 7 electrons in its valence shell, 7 electrons, the easiest way for it to attain configuration, octet configuration is for it to accept 1 electron so that it can have 8 valence electrons. So in this example of sodium chloride, sodium loses 1 electron. Then the chlorine atom gains the 1 electron so that it will not have a complete valence. So what we are saying here is that the sodium atom will lose electrons. So minus 1 electron, it will have sodium ion. And then the chlorine atom will gain 1 electron to now become a chloride ion. So that is how sodium and chlorine combine together to give you sodium chloride. And as you can see, once an element loses an electron, it becomes a positively charged ion. If it gains electron, it becomes a negatively charged ion. So what is holding electrovalent compounds together is these opposite charges, the positive and negative charges. You learned in your physics or from your primary science that unlike charges attract, while like charges repel. So these are unlike charges, plus and negative, so they will attract each other. So what is holding these compounds together in electrovalent bonding is this opposite charges, the positive and negative charges binds them together. That's why you call it ionic bonding. It's a bonding due to the presence of ion. So it binds them together. So looking at it in another way, I've drawn the shells here. If you are looking at it in shell form, okay? This is the electronic configuration of sodium using the shell. The inner and first shell has 2 electrons. The second one has 8. The outer one has 1, giving it 2, 8, 1. Then for chlorine, this is sodium and this is chlorine. So for chlorine, it has 2 electrons in the inner first shell, and then 8 electrons in the second shell, and 7 electrons in the outer shell. So what happens here is that this sodium loses the electron by transferring it to this chlorine atom. And if that one happens, you see if this electron is gone, this sodium will no longer have need for this outer shell because it is now empty. And that's why we have only 2 shells here. It will only left with these 2 shells. We're having an electron configuration of 2 and 8 because the outer shell has lost its electron, so it is gone. So sodium ion will now have this. This is a sodium ion with this electronic configuration 2 and 8. Then for chlorine, once it gains that electron, it will now have 2, 8, 8. The outer electron will now have, let me write this in red to know that this is the one that came from the sodium. So that will now give it 8. If you count the number of electrons here, you see there are 8. So the chloride ion will now have the 2, 8, 8 electronic configuration, and that's what gives you sodium chloride. So that is one example. We'll take a look at one more example before we go to the next type of chemical bonding. Right, the second example we'll be looking at is the formation of calcium chloride. Calcium has atomic number 20, electronic configuration 2882, and if we are drawing it, this is how it will look like with 2 electrons in the outer shell. and it's combining with two chlorine, just like the formula shows. Because there's no how calcium will lose 2 electrons, and if it's combined with only 1 chlorine, it will accept only 1, and then where will the other one go? So it must combine with 2 chlorine atoms. Each of the chlorine atoms needs one electron to complete their outer shell. This one needs 1, this one needs 1. So the 2 electrons from the calcium atom, one will move here, one will move here. Okay? So, and doing that, the calcium atom will lose this 4th shell. It will be left with only 3 shells, complete outer shell with 288 as its electronic configuration. Then each of the chlorine atoms will now complete its outer shell, having 288, and then the shells will look something like this. So that is how the calcium calcium chloride compound is being formed by ionic bonding. Now let's quickly look at the properties of electrovalent or ionic bonding. Okay, the first property we have is that ionic compounds do not contain molecules. Instead, they consist of aggregates of positive and negative ion. They don't form molecules. You don't say a molecule of sodium chloride. Okay, rather they are aggregates of ions. I told you initially that the positive and negative ion is what holds the atoms together in an electrovalent bonding. So they form a 3-dimensional crystal. That's why if you look at the common salt, which is what we call sodium chloride, you see that they are crystals. They are crystalline. Okay. And the second property is that they are solids at room temperature. All ionic or electrovalent compounds are solid. Okay, this is not bonding. This is properties of electrovalent or ionic compounds now. Compounds. Okay, they are solids at room temperature. Next, they have high melting and boiling point. The fourth one, ionic compounds readily dissolve in water and other polar solvents. You know water now, if you put your salt there, which is your sodium chloride, it dissolves in it. So they are soluble in water and other polar solvents. They conduct electricity when molten or in solution. Mind you, we say when molten or in solution. That's the only condition under which they will conduct electricity. When they are in solid form, they will not conduct electricity. Because the electrons, the ions must be free to move. If the ions are not free to move, they cannot conduct electricity. So when you dissolve it in water or they are in molten form, they will disintegrate so that each ion is free to move. Then when you connect electricity through an electric wire, then the ions will move, thereby conducting electricity. So in other words, you can say that they are used as electrolytes. Okay, because electrolytes are compounds which when molten or in solution can conduct electricity. The sixth property is that they do not dissolve in non-polar solvent. Up here we say they dissolve in polar solvents like water. But here we are emphasizing that they do not dissolve in non-polar solvents. What are examples of non-polar solvents? Okay, like toluene, benzene, trichloromethane, even kerosene or petrol that we commonly know. All those ones are non-polar solvents, and then ionic compounds will not dissolve in such compounds. So we are going to stop this lesson here. In our next lesson, we are going to talk about covalent bonding and the other bonding. But before we go, let's take an assignment that we will do before we meet in the next lesson. Now, this is the assignment that we have for today. You do this assignment and submit it to my WhatsApp through this number written at the end of the assignment. See you in the next class.